Look at something across the room right now: a clock, a word on a label, the face of someone you love. Is it sharp, or is there a soft haze around the edges that was not there 5 years ago? Most people with blurry vision do the same thing. They go to the eye doctor, they get a stronger prescription. 6 months later, the prescription needs updating again. The glasses get stronger and the vision keeps getting worse. Here is what almost nobody tells those people: the glasses are not treating your vision problem, they are compensating for it. And the reason your vision keeps deteriorating has almost nothing to do with your eyes. It has everything to do with what is happening in your blood right now. You have probably heard diabetes mentioned in connection with vision loss. But here is what that conversation almost never includes. You do not need to be diabetic for blood sugar to be destroying your eyesight. You do not need a diagnosis. You need something far more subtle and far more common: blood sugar that spikes and crashes throughout the day, that runs slightly too high for slightly too long. That pattern, which research suggests affects the majority of Americans over 55, is quietly damaging the most metabolically vulnerable tissue in your entire body: your retina. I am Dr. Robert Anderson, and today I am going to show you exactly how this happens inside your eye and the specific daily protocol that addresses each mechanism, including one practice you can start tonight that costs nothing and directly protects your retina while you sleep. I will explain that one at the end. But first, before anything else, I need to name the symptoms that mean stop watching and call a doctor today. Sudden vision loss in one eye that came on in hours or days. A curtain or shadow moving across your visual field. A sudden flood of new floaters appearing all at once. Flashing lights in your peripheral vision that come and go repeatedly. Any one of those signs points to acute retinal damage or detachment. These are emergencies requiring same-day ophthalmology evaluation. Nothing in this video applies to those situations. If what you have is gradual blurring that has worsened over months, difficulty reading fine print, halos around lights at night, a general haziness your glasses no longer fully correct, then stay with me, because what I am about to describe is almost certainly happening in your body right now. Here is the first mechanism, and most people have never had this explained properly. Your eye's lens sits just behind the pupil and focuses light onto the retina. It has no blood vessels. It absorbs glucose directly from the fluid surrounding it. When blood glucose rises rapidly after a meal, the glucose in that surrounding fluid rises with it. Inside the lens, that glucose gets converted by an enzyme into a compound called sorbitol. And sorbitol cannot leave the lens. It accumulates, and because it pulls water toward itself, the lens physically absorbs water and swells. A swollen lens cannot focus correctly. Things that were sharp become soft. This is not a permanent structural change, it is a fluid shift, it is reversible, and it explains something that confuses millions of people: why vision is noticeably worse some days than others, why it is sharper in the morning before eating, why a prescription from 6 months ago suddenly feels wrong. Your lens is literally inflating and deflating based on your blood sugar. The second mechanism is slower and more destructive. The retina is fed by the smallest blood vessels in the human body, capillaries so fine that red blood cells pass through them single file. These vessels are the lifeline of your entire visual system. Without them, the photoreceptors, which are the cells that convert light into the signal your brain reads as vision, receive no oxygen and no repair capacity. Chronically elevated blood sugar damages these capillaries through a process called glycation. Glucose molecules attach to proteins in the capillary walls, chemically bonding to them and deforming their structure. The walls stiffen and thicken like a rubber hose, slowly turning to ceramic. It loses flexibility. It develops leaks. When the capillaries feeding your retina begin to leak fluid and blood seep into surrounding tissue, and the retina swells. This is the beginning of what clinicians call diabetic retinopathy, but the underlying process begins years and sometimes decades before any diagnosis. You do not need a diabetes diagnosis for this to be happening. You need cumulative glycation exposure, and that is a function of how high your blood sugar runs and how often, not whether a number on a lab test has crossed a clinical threshold. The third mechanism targets the macula specifically. The macula is the small central region of the retina responsible for your sharpest, most detailed vision. Reading. Recognizing faces, seeing fine print. It contains two protective pigments called lutein and zeaxanthin that absorb blue and ultraviolet light before it can damage the photoreceptors underneath. Chronic blood sugar dysregulation floods retinal tissue with oxidative stress and free radicals that deplete these pigments faster than the body can replenish them. When the protective pigment runs low, light reaches the photoreceptors unfiltered. Damage accumulates, visual acuity falls. Most people over 60 are already low in these pigments because their diets are low in dark leafy vegetables. Add blood sugar dysregulation, and the depletion accelerates significantly. Now here is what I want you to stay for. 3 nutrients are specifically critical for retinal health and specifically depleted by everything we have just covered. Thiamine, which is vitamin B1, is essential for glucose metabolism in retinal cells. When blood sugar is chronically elevated, thiamine is consumed at an accelerated rate, processing the excess glucose load. Thiamine deficiency in the retina impairs the cells that carry visual signals to the brain. The signal does not disappear. It degrades. Vision becomes less sharp and less crisp, even when the structural health of the eye appears intact on imaging. Magnesium is involved in over 300 enzymatic reactions, including the mechanisms that regulate blood vessel tone and protect neural tissue from oxidative damage. It is also required for proper insulin signaling, which means magnesium deficiency makes blood sugar dysregulation worse, which increases retinal damage, which is why the two conditions compound each other progressively. Clinical research estimates the majority of Americans over 60 are insufficient in magnesium, and most have no idea because magnesium is not included on a standard metabolic panel. Zinc. The retina has one of the highest zinc concentrations of any tissue in the human body. Zinc is essential for the biochemical sequence by which light signals are converted to neural signals, and for the enzymes that protect retinal tissue from oxidative damage. Zinc absorption decreases with age, particularly in people whose stomach acid has declined, which is the majority of people over 60. 3 nutrients, all depleted by the same metabolic conditions driving the damage, and all replenishable through specific accessible foods. Here is the practical protocol. Start every morning with a blood sugar stable meal before consuming any simple carbohydrate. 2 eggs with smoked fish or full-fat plain yogurt with ground flaxseed. A morning meal built on protein and fat blunts the early glucose spike and reduces sorbitol accumulation in the lens during the 2 hours after eating. The morning glucose response sets the metabolic tone for the entire day. Add cooked leafy greens during the morning or early afternoon. Cook spinach, kale, or collard greens rather than eating them raw. Cooking breaks down the cellular walls that lock lutein and zeaxanthin inside the plant. A half cup of cooked spinach delivers more bioavailable lutein than 3 cups raw. Always add a teaspoon of oil or butter alongside. Lutein and zeaxanthin are fat-soluble, and without fat in the same meal they pass through without being absorbed. During the day, apply one rule at every meal: fiber and protein first, starch and sugar last. When you eat vegetables and protein at the beginning of a meal and starchy or sweet foods at the end, glucose enters the bloodstream at roughly half the rate compared to the reverse order. Same foods, different sequence, dramatically different blood sugar response. Walk for 10 minutes after your 2 largest meals. Muscle contraction during and after eating pulls glucose out of the bloodstream directly into muscle tissue without requiring insulin. A 10-minute walk after dinner reduces the post-meal glucose peak by a clinically meaningful amount and is the lowest-cost retinal protective intervention available to anyone. In the evening, a small handful of raw, unsalted pumpkin seeds provides a meaningful dose of both zinc and magnesium in highly bioavailable form. 2 or 3 servings of herring per week provides thiamine alongside vitamin D and omega-3 fatty acids that directly support the structural integrity of retinal cell membranes. 2 egg yolks daily provide lutein and zeaxanthin in the most bioavailable form of any food because the fat already present in the yolk ensures full absorption. And stop eating at least 2.5 hours before sleep. The photoreceptors that worked all day rebuilding their light-sensitive outer segments perform this repair during deep sleep. A blood sugar spike during that window competes directly with the repair process. Give the retina its recovery window by giving the digestive system its rest window. Your vision is not failing because you are getting older, it is failing because it is being bathed in a metabolic environment that is slowly damaging the finest blood vessels and most energy-intensive tissue in your body. That environment can be changed. Not with a procedure. Not with a stronger prescription. With the sequence of your meals: a handful of seeds, 2 egg yolks, and 10 minutes of walking after dinner. The same vascular mechanisms damaging your retinal capillaries are running simultaneously in your kidneys and your heart. These are not separate problems. They share the same origin. In the next video, I am going to show you how to identify the specific blood markers that reveal whether this damage is progressing and what the research says about reversing it at the capillary level. Subscribe so you do not miss it.